AP walkthrough for today. So first one on our list was problem number 6, the 2019 free response questions. We're given g of 2 equals h of 2 equals 4. We're given that this line is tangent to both g and h at x equals 2. Part A asks us to find h prime of 2, so the derivative at 2. Now the derivative is the slope of a function. The way I interpret this is that since we have a tangent line at that point, the slope of the tangent line matches the derivative at that point. So the slope of our tangent line is 2/3. Therefore, our derivative at that point is 2/3. Second part, a is some function, such that we have 3x cubed multiplied by h of x. We want to find a prime of x and then a prime of 2. Looking in advance, we're going to have the product rule here. So a prime of x is 9x squared h of x plus 3x cubed times the derivative of h, which would be h prime of x. Now we want to find a prime of 2. It's going to be 9 times 2 squared multiplied by h of 2 plus 3 times 2 cubed multiplied by h prime, h prime of 2. So we can evaluate going through. We've got 9 times 4. h of 2 we're given is 4 plus 3 times 8. h prime of 2 we had from the last is 2/3. So that is 16 times 9 is 144. That 3 and that 3 plus 16, we have 160. C tells us that h satisfies x squared minus 4 over 1 minus f of x cubed for x not equal to 2. We can use L'Hopital's rule for evaluating the limit as x approaches 2 of h of x. Since L'Hopital's rule applies, that means, well, if we look, 2 gives us 0 in the numerator. That means we also have 0 in the denominator down here. That tells us that 1 minus f of 2 cubed is 0. Or f of 2 cubed is 1, and f of 2 is 1. So first part solved. We also want to use this limit to find that. I also want to find f prime of 2. Since we can use L'Hopital's rule, that's going to give us then that a limit as h approaches 2, h of x is going to be the derivative of the top, the derivative of the bottom. It's going to give us 2x over, well, we already know that this equals 4 because we are twice differentiable. Twice differentiable implies that we are continuous at the start. So we know that this equals 4 at 2 from the very start. Derivative of the denominator is going to be negative 3 f of x squared times f prime of x. Chain rule in there. Working through, we know this equals 4, so we've got 2x over 4 equals, I'm going to cross multiply. That's negative 3 f of x squared, it's sloppy, I recognize, equals f prime of x. And we want to evaluate for 2, so we've got 2 times 2 over 4 times negative 3 times f of 2 squared equals f prime of 2. 4 and 4. F of 2 is 1 from before. 1 squared is 1. We have 1 over negative 3. part D, we are known that G is less than or equal to H. 4, 1 is less than x less than or equal to 3. K is some function that G of x is less than or equal to K of x is less than or equal to H of x. For 1 less than x less than 3. Is K continuous? We know that G is continuous because we are differentiable. We know that H is continuous because we are differentiable. We know then that the limit as we approach any value there equals the value of the function. Now, because K is always in between two continuous functions, doesn't matter what G is, doesn't matter what H is, whatever's going on with K, it's always in between those two. And since those two come down and are equal at that point, we're using what's called the squeeze theorem. A squeeze theorem implies that K is continuous at x equals 2. It has to be in between those two curves.